I wonder why some things are easier to move than others. Have you ever tried to move a grocery cart full of items and noticed that it's much harder to move than a grocery cart that's empty? That is because of something called inertia, the tendency of an object to resist changes in motion. According to our textbook, Newton's first law states that an object at rest stays at rest unless acted upon by an external force. But how does this apply to the tiny particles inside of an atom? Let's find out. This rubber band represents electrostatic force. That's the force that attracts negatively charged electrons to positively charged protons in an atom. But do electrons and protons move the same when we apply force to them? Let's investigate. This small, light-weighted bear represents an electron. Electrons are incredibly small, with a mass nearly 2,000 times lighter than a proton. I wonder how that affects movement. So, as you see, I attached my rubber band to my teddy bear. If I pull on the rubber band, what do you think will happen to my electron or teddy bear? Wow, it moves so easily. How did that happen? That must mean that an electron doesn't have much inertia. So they accelerate quickly with just a small force. Now, let's see if protons will act the same way. This is a very heavy backpack. This will represent our proton. According to Tillery, protons have a mass about 2,000 times heavier than an electron. That makes me wonder, if I attach my electrostatic force, what will happen to my proton? So I'm going to attach. What do you think will happen when I pull on it? How did that compare to the electron? It barely moved. Why do you think that is? That's because the proton has a greater inertia than my teddy bear electron. Even though the same force is being applied, the proton resists movement much more because it has more mass. It takes a much larger force to get it moving.